Okay, so yesterday all the problems gave us the amount of time that was going to pass and asked us to find the new amount. Today we're going to be doing problems that are going to involve finding the amount of time. So here it's asking the growth of a bacteria in a dish is modeled by the function f of t, for which value of t is f of t equal to 32. So it's basically asking what would the time have to be for the new amount to be 32. So if you look at the calculator on the side of my screen, I've graphed both functions. I graphed f of x equals 2 to the x over 3 power. I'm using x instead of t. And then for the second one, I could write f of x if I wanted to again, but instead I just put y equals 32. So for the constant function, I'm probably just going to do y equals whatever the constant is. And now if I press on the intersection point, I find that at 15 is where the function reaches 32. So, great. My pen's not working. So I get the answer of 15. So to develop today's lesson, case 1 is going to be just recalling what we did yesterday, simply plugging in a time and finding a new amount. So here's an example for case 1 right below it. If $5,000 is put into a savings account that pays 3.5% interest compounded, I'm going to make this compounded annually, because we didn't do monthly yet. How much money to the nearest 10 cents would be in the account after 6 years, assuming no money was added or withdrawn? So I'm going to put y equals a times 1 plus r to the x power. We'll look at this actually the next day, tomorrow, where we could do monthly. So I'm putting 5,000 as the starting amount, times 1 plus 0.035 to the 6th power, because that's the time that goes in for the exponent. So I'm going to put in 5,000 times 1.035. Now be careful today when you're making the percents into decimals. You guys had trouble with that yesterday. To the 6th power. So they have the answer to this question, which would have been a common wrong answer to the original. Instead of 27 cents, rounding to the nearest 10 cents, it said is 30 cents. So that's this answer right here. Okay, if it's compounded monthly, it would be even more money. So I'm guessing the answer was choice 4. For case 2, finding time. So here they give us the function, so we don't have to plug in. They give us the function for v, and they want us to find how many years to the nearest tenth of a year will it take for the amount of money to reach $1 million. So they give you the function, they're not giving us the information to plug in, and they give us how much money they want the original $1,500 Drew's parents invested, which you could see as the coefficient in the equation, when it will turn into $1 million. So all we need to do for this is graph the function 1,500 times 2, and then as the exponent, we're going to put x divided by 7. And then for our second function, we're going to put in y equals, you can't just put the 1 million, it's not going to change a constant into a function. So you have to put the y equals 1 million. And then for 1 million, well, you know what, let's do the zoom to fit. Okay, that helped me get there. Okay, if you press the settings gear on the top right of the calculator, you get the standard view or zoom to fit. So I just did it again, but I have that point of intersection of where the constant function 1 million crosses the exponential function, and the x value 65.6657. That's the answer, but it wants it to the nearest tenth of a year. So it's going to be 65.7. So in all the questions, it's highlighted what you're rounding to. So case 2, instead of plugging in, we're just graphing the two functions and finding the point of intersection. Okay, number 2. The numbers are all messed up. I just picked the ones I wanted to use. Given a starting population of 100 bacteria, the formula, so they plugged it in again. They put that original population of 100, they put the doubling in there as the base. But here they tell you that B is T periods of time. If each period of time is 15 minutes, so this part we're going to have to use at the end to just answer the question. How many minutes will it take for the population to reach 51,200? So again, in the calculator, and you're going to explain this in your work, I want to see, okay, I graphed B equals 100 times 2 to the T power. I graphed Y equals 51,200. And then I could even see a little sketch of the graph. It's just going to be, we're only interested in the first quadrant here. So 2 to the x power, that's our first function, and then y equals 51,200. So I have to put that y equals before the constant function, otherwise it's not going to graph anything for me. So I'm going to hit the gear, you can't see me pressing, zoom to fit, and then I have that point of intersection right in there. So I can make a little graph sketch to show for my work, and then I could put x equals or t equals where they meet 9, exactly 9. But that, going back to what it said before, that x value or the t value is the number of time periods, and each time period was 15, so you actually have to do 9 times 15, just a little extra, which is 135, I believe. So 135 minutes would be the final answer. Number 6, I think this is the last one, and then you're going to try the next two. So again, it gives you a whole spiel about where the numbers come from, but they're giving you the population of this area. They're giving you a function for it, where P of T represents the total population and T represents the number of years from now. Find the population of the Waterville area to the nearest 100 7 years from now. So A is a case 1. They're giving you the amount of time and asking you for the new population. So for that, I'm just going to plug in 7 for the T and find out the new population, and then I have to round. So clear that. 62,700 times 1.0325 and to the 7th power. So 78432.844, but they want to the nearest 100. 4 is in the 100th place, so it's 78,400 would be to the nearest 100. So that's part A, which is a case 1 type of problem. Now let's look at part B, which is a case B. They're asking to determine how many years. So when they're asking how many years, that's when you know it's a case 2 problem. To the nearest 10th will it take for the original population, that's 62,700, to reach 100,000. So I'm going to graph P of T equals 62,700 times 1.0325 to the x power. No, sorry, if I'm writing P of T, I have to put T. And then the second one, we want to graph y equals 100,000. I could put a little sketch of the graph, clearing it out. 62,700 times 1.0325, and then we're going to put an exponent of x. Okay, that's in terms of x. I could zoom to fit just to look at that graph. Oh, I just want to get back to there. Okay, and then you don't even see a curve. It's the way that they're showing it. And then 100,000. Oh, I forgot to put the y equals, so that's what happens. It gives you that slider. Y equals 100,000. And now I'm going to zoom to fit again. And here I get the point of intersection. And it wants to the nearest tenth. So it's, here I could put a little sketch to show, actually, and I'll put the answer there because that's what I want to see for your explanation and your work. X equals, or t equals 14 point to the nearest tenth, 5, 9, so nearest tenth is to this 0.6. And that's our answer. So this is a good last problem to do together because we see a case 1 and a case 2 type of problem. These are case 2 and case 2 asking for time. For number 7, you're going to have to plug in the rate for R. So you're going to do 1 minus the 0.3. All right. Also, you have to remember to put in the C, 15,000. Okay. So let me see you. For number 7, you have to figure out the function before you graph the two. Show me the point of intersection. And then for number 8, they give you the function. It's like all of those. Oh, but this one actually I see is a little tricky because they're saying to find to the nearest tenth of an hour how long it takes to half the drug dose. Well, if it's starting at a 10 milligram dose, you have to figure out what the constant function is. Y equals half of that. All right, so I think you could all figure out what half of the 10 milligram dose is. Again, reach out to me if you have any questions.